Until probably a year and a half ago, all of my code sucked. 4 years of college, 3 internships, and not only did I not write good code, I didn't even know my code was bad. And chances are, especially if you're still a college student, you're probably making some of the same mistakes that I was. So these are a few of the lessons that I've learned over the past couple of years that have really helped me level up as a software engineer, so hopefully you can take some of these lessons and apply them to your own work. Alright, the first thing I want to talk about is testing. Now, I don't think I wrote a single line of test code while I was in college, which, when you think about it, at least on the surface, isn't that surprising. For the most part, I was working on small assignments on relatively tight deadlines, which meant that instead of writing full test coverage, you just did either manual validation, or if you were lucky, your class had an auto-grader and you could just run your code through that. But the issue with that is, even if we didn't have to write automated test code as part of those assignments, just the act of learning how to write good test code is super valuable, and it's something I think everyone should know how to do before they graduate from college. But taking a step back, why is learning how to write automated test code so important? So in the short term, there doesn't seem to be a super compelling use case for why you need to write test code. You write your program, then you write a full test suite for it, you execute it, and you make sure that everything passes. In that time, you probably could have just done manual validation. It would have been quicker. As long as everything seemed to be working, you could have just moved on. But it's in the long term, especially for larger scale projects with multiple contributors, that writing test code really starts to pay dividends. As your code base gets bigger, more entangled, and tech debt starts to build up, your devs are going to have to spend more and more time chasing down bugs as they creep into your code base, giving them less time to work on features. And for a lot of legacy projects, it gets to a point where people are afraid to make changes to certain parts of the code because they know that one change is going to break 5 other things. And once you get to that point, your code basically starts to rot because you can no longer support it and you can't safely build things on top of it. Having a strong set of test coverage means that doing a refactor doesn't need to be a super stressful experience. Now, assuming you have good test coverage, which is a big assumption, then assuming you run your test suite after adding some new functionality and everything is still passing, then you can probably have a high degree of confidence that you didn't break anything, at least not anything too significant. And as great as I'm sure that probably sounds, that is significantly downplaying the amount of time, effort, and expertise that goes into writing a test suite that really has that level of coverage for your app and isn't going to completely break anytime you do a refactor. I'm not going to dive into the technical side of what it means to write good test code in this video. It's too big of a topic. It would need its own video. But just understand that this is a legitimate challenge. For a lot of devs, managers, or customers, the process of writing tests is considered to be time-consuming and reduces velocity, which is entirely valid, given that writing a feature can take twice as long, if not longer, to add in the proper test coverage. And the problem is you don't really see most of the benefit of writing tests until the long term, which is something that's pretty easy to ignore when you're under a tight budget and tight time constraints. But if you don't take the time now to write good test code, you're going to get burned down the line when you start having regressions or manual validation just becomes too unwieldy. And trust me, it's a heck of a lot cheaper and saves a lot more time to do it right the first time than having to do a complete rewrite of your system because it's just gotten too out of hand. So, I'm not going to talk about object-oriented programming or different architectural patterns or a whole bunch of other things that you maybe have heard about that are all super important because a lot of those topics are too complex to get into in this video. I want to go down to the most fundamental level of writing code and what I remember learning, and probably more importantly not learning in my first year of college, that should be driven into everybody that studies computer science. Which is, contrary to what you've probably been told in your college classes, writing comments should be seen as a bad thing, at least most of the time. Now, I realize this might seem a little counterintuitive. If you want your code to be cleaner, why would you pull out all of the comments that are explaining what's going on? Isn't it just going to be more confusing that way? The real issue here, though, isn't actually the comments themselves. It's that a lot of new developers abuse comments. If we take a step back, comments are meant to help describe code. They can make your life and your collaborators' lives a lot easier in the future by helping clear up something that wouldn't be immediately obvious by looking at the code. And as a result, a lot of new developers are encouraged to comment extensively to make the code as clear as possible, when in reality what they should be focusing on is making the code itself as clear as possible. Okay, there's a pretty good chance that you or someone you know is guilty of having done this. I've done this myself many times. Naming a variable my num, or I, or j, or j2. If you didn't notice, the common trend with all these names is that none of them are descriptive of the variable's intent. Being careless about naming can turn even the simplest of methods into an unreadable mess, which is why a lot of people then turn to commenting to help make sense of it. In the best case, you now just have to read twice as much to understand what the heck is going on, because you're going to read the code, it's not going to make any sense, and then you're going to read the comments to help describe what should have been obvious in the first place. But in the worst case, the code either gets updated or moved to a new location or completely removed, and if that comment isn't moved with the code or updated correctly, that comment is now doing more harm than good because it doesn't reflect what's actually going on. All that being said, I do feel like I need to emphasize that comments are still a very valuable tool in situations where the code really can't adequately describe itself because it's unintuitive or it's confusing. But you should get in the habit of asking yourself anytime you go to write a comment, why you need to write that comment, why you think the code can't adequately describe itself. Because even if it's more work in a lot of cases, you should probably try to refactor the code to make it easier to understand and follow the single responsibility principle, for example, as opposed to just slapping a comment on it and calling it good. One of the biggest issues with most of the coding assignments that I had coming up through college is that I never had to consider how real-world users were going to interact with what I was building. And that's because in most cases there were no real-world users. Homework assignments let you make a specific set of assumptions about what your code needs to be able to do to earn a certain grade, but all that goes out the window once you start working on production code. First off, when you're taking any sort of input from a user, you really can't make any sort of assumptions about what that input is going to look like. Just because you're only expecting a certain kind of input, whether that's an integer or a string or only English characters, doesn't mean your users aren't going to try to provide something different. Which is why anything you take in from user input, whether it's files or text or anything else, needs to be treated as potentially unsafe until you have the opportunity to properly sanitize it. Failing to do this might mean that users are able to do things that they're not supposed to, like having a credit card number that's not the right length or having a name that's only blank spaces, but in the worst case, it can open you up to either malicious behavior or could completely crash your system. And the second thing I want to talk about when it comes to user assumptions is something known as Hiram's Law, which states, with a sufficient number of users of an API, it does not matter what you promise in the contract, all observable behaviors of your system will be depended on by somebody. Basically, however your system behaves, regardless of whether that was part of the original plan or if it was intentional, assuming you have a lot of people using that system, then someone's going to start relying on that behavior. And this is important because making breaking changes is a really big deal. Altering or removing a piece of functionality that your users are depending on is going to break their scenarios, which naturally they're not going to be happy about. So it shouldn't be something that's taken lightly. But what happens when people start relying on behaviors that you never explicitly specified, and then you want to change it? For example, in the beginning, let's say you're using a list as a backing data structure for some data that you're going to show users. You don't make any guarantees about ordering, but they happen to notice that everything always comes back in a specific order and start making assumptions based on that. Then let's say down the line, for efficiency reasons, you switch over to using a dictionary, which doesn't make guarantees about ordering. All of a sudden, everyone who's relying on that behavior of things always being in a certain order is going to have their scenarios broken. On the one hand, you didn't do anything wrong. You didn't explicitly make any guarantee about the ordering, and people chose to make that assumption, which is on them. It's very easy to say that in theory versus in practice when you have a whole bunch of really angry users who say that something has regressed and they no longer have ordering, which is really important to their scenario. And by you deciding to make that one internal change, you've now broken a bunch of things for them. Especially when a lot of people start relying on an unintended behavior like this, it either locks you into supporting something that you've never really intended to support, or just annoying a lot of your customers, neither of which is really ideal. Which is why it's really important to be intentional about designing how users are going to interact with your system, regardless of what the documented behavior is supposed to be. It's hard to be perfect on this because you never really know what exactly users are going to latch onto and start depending on, but taking some time to think about edge cases and how users might interact with this in a real-world setting can save you a lot of headaches down the line and keep you from having to support certain behaviors that you really don't want to have to support, or just really irritating a lot of your user base. All right, there's a lot of stuff I left out here, so if you want to see a part 2, make sure you let me know, and subscribe if you haven't already so that you can see all of my future videos as soon as they come out. Anyways, that is it. Thanks so much for watching, and I will catch you guys in the next one.